Hi everybody, this is Tor Storley and I am back with another video. In this video we're going to take a look at Polars. The super fast Rust library can be used for data frames and also for all kinds of logic, much like pandas have been used. So it's much faster than pandas. In this video we'll look at Polars. I'll go through a few things in Polars. There's no way I can cover it all. If you do want me to get an in-depth multi-video series using Polars, let me know in the comments. So I created this Jupyter Lab notebook, and I think I'm going to keep it in the light mode in this one, so it's easy to see it instead of getting too dark all the time. The first thing we're going to do is import some libraries. And the first one you're going to need is Polars. From Polars, I'm going to import selectors because we're going to use it to look into columns and so forth. And we're also going to use it for great tables, which we're going to cover in this video, how you use Polars with great tables. So the first thing we need to do is create a data frame. So here is a made up data frame that basically has some people, as you can see here, and which department they are in, and their salary, and the number of years they've been there, you can see, and whether they work remotely or not, and the start dates. So you can see what time the start date was, okay? And then, of course, we have a data frame. So notice this data frame is based on PL, which is Polars, because we imported it as PL, as you can see up here. So what I've done is I created some cells. I added some comments on the top here so it becomes easier to follow this. So the first thing we need to do is run this. Now you have a couple of options here. So what I tend to do is I just put my cursor somewhere in the cell and hit Control Enter. So Control Enter, and it ran. And now you can see here is the data frame we're going to be working with. Now, first thing we probably want to do is get an idea about what we're looking at here. So we can look at the shape of this data frame. How many rows are there? How many columns are there? And if you run that, you're going to see there's 8 rows and 6 columns. Now what I'm going to do here is I'm going to reset the kernel, okay? Kernel, restart kernel, and clear all outputs. That's kind of what I want. All right, so that looks a little better. So let's redo this now. So you can see there's no numbers here, so it hasn't run anything yet. Control Enter, and it's running. Importing these libraries, done. Creating a data frame, done. And here you can see the data frame. And then we're going to start doing some checks on what we have created. So let's look at the schema and the shape. All right, so there's 8 rows, 6 columns, okay? Now we can look at the schema by using the DataFrame.schema method. And as you can see, the name column is strings, department is strings, salary is an int 64, years is an int 64, and remote is a boolean, and start date is a date. Okay, we can also describe it, much like you do in SQL queries. So here you can describe, the counts, the means, the standard deviation, the quartiles, the median of 50%, and so forth. So you get an idea what we're looking at here. And you can also analyze the data to see if there's problematic data in here. Now, this is a very simple data set, so I don't expect this to be too many problems here. Okay, you can also do a head function, and you can set up how many rows you want to see. In this case, 3. So here are the first 3, because it's the head function. The tail will show you the last 3 in this case. So hit that, you can see now you see the last 3 rows. You can also select individual columns. For example, by making it into a list object, you can simply refer to the column names you want to include. So here you can see name, salary, and department, just like that. You can also figure out which one of these columns are numeric. And this is when we use this CS, which is the selector, which is this portion of it. That we're going to use that later too in the great tables section. So we're going to use that selector, and we're going to find all the numeric columns. So here you can see there's 2 numeric columns. It's the salary and years. Then what we want to do is we want to find all. We're going to use this all selector, and then we want to subtract these 2 out of it. So we're going to show everything but these 2. So hit enter, and sure enough, the remote and the start date is gone. Now, we can also filter the data. Here, I only want to see rows where salary is greater than 80,000. So let's run that, and you can see here all of these numbers on salary are greater than 80,000. I can also use and or expressions. But notice we use the PL call to refer to each of these columns. So here we're filtering the department column where the rows in that column, meaning the values in that column, is ENG and, okay, and the remote is true. So we only want to see the English department and not working on premise. And here you can see true and English. And here we want to just find out who is in the HR and the MKT department. And you can use this function, is in. So let's run that. And all of these should either be in the HR or the marketing department, as you can see. You can also add columns or transform columns, meaning you create new columns, if you will, by using this with columns. A lot of things in Polars brings me back to the days when I was working with Palantir Foundry in the corporate setting when we were writing PySpark code. A lot of these are very similar. And I'll point out a couple of them as we go. One of them is this one here. And you can also create a literal, okay, as you can see down here. But I'll get back to that. So here what I'm saying is we want to add a new computed column using this with column. And what we're going to do is we're going to take the existing salary column, divide it on 12, and then we're going to round it, and then we're going to call it this, okay? And here you can see what that turns out to be. So that'd be these numbers over here. So that was the original salary. Divided on 12 is this monthly salary. We can also use if-like statements like when, then, otherwise. If the salary is greater than 90,000, your senior status. If the salary is greater than or equal to 75,000, you're mid-level. Otherwise, you're a junior. And here we're using this lit, which is basically a literary function that you can write text out that kind of repeats itself. So let's run that, and we're going to call it level. So here you can see we're creating a new column, and we call it level. All right, very good. Now, we're getting into the schema. And what we can do is we can use this with column, where we base it on the years, and then we're going to cast it into a float. So we're changing the data type. Remember, years was, if you look up here, years is an I-64. Now I want to make a float out of it. So let's hit that. And when you look at years now, you can see it's been changed to a float. A lot of times in data, if you especially have a lot of data, it might be an idea if you know the numbers limits, like ages. I mean, how many people are getting 200 years old? I don't know of any, do you? So the point is, you probably don't need an int64, okay? You could make it much smaller, so it takes up less storage, especially if you have a need for streamlining this and make it, more compact. Anyways, I just want to point that out. So you can change the data types, in other words. So we're going to create a new column, and we're going to call it higher year, as you can see. So we want to extract out of the date, we want to extract the year, as you can see here, and then select the columns that we want to show. So let's hit enter there. And there you can see you're getting the year out of the date itself, like from here. And that's what we call an .dt accessor. Now, you can also sort by using descending is true or false, what have you. So here we want to order it descending. And we only picked the first 4 rows. So let's run that, and you can see here we are sorting by salary. The highest numbers first and the lowest numbers last, like this. And you can also do double sort. So in other words, I will sort on the department and salary. So I'm saying I don't want to descend the department names. I want them alphabetically. But I want to show the highest salary like this in order. So when you run that, you can see here, this is still the highest salary, but these are now in order alphabetically. You can use GroupBys by doing this DataFrame GroupBy and whatever you want to group by, in this case, department. By using this .ag function or functionality, the grouping ag function, I should say, you can actually go against different columns and do aggregations. So you can see here, I'm doing mean, a max, min, count, and a mean. So there's like 5 of them here that is going to fall under this aggregation. So it's multiple aggregation at once, so you don't have to do individual ones. You're going to see Here's the max, min, head count, etc., etc. You can also do some categorical columns, for example. So here you got the name. You want to do counts, and you want to give it a new column name by using this dot alias. So you call it count, and then you want to sort it. When we run this now, you can see you have 4 juniors, 2 mids, and 2 seniors like this. So that's how you can also use this ag function and do some nesting here. Actually, what this is called, it's called a chaining. I should be precise here. So basically, you perform an operation, and then you chain it to the next command, and you chain it to the next command, and so on, so on, so on. Behind the scene, Rust, or in this case, Polar, so it's a lot more efficient, this chaining method. You can also do Windows function, much like you do in SQL. And you might recognize if you're in SQL, or if you have used SQL, you can see this over keyword, right? You might have lead or lag function over a certain window frame, right? So here what we want to do is we want to take the mean of the salaries, but we want to create a Windows function over the department. So we would run this, and then from there we're going to select. So let's see what that looks like. And as you can see, for the English department, the mean salary is 95,000. So it repeats because it's the same average for all of those guys in the HR. Okay, if you only want one of them, you have to find a way of selecting only one from each grouping. All right. You can also rank employees within each department by the salary using a Windows rank expression like you can see here. So here we're taking the salary and we rank it in descending order. So we're going to sort it from the highest to the lowest over these departments, these guys, ENG, HR, MKT. And then what we're going to do is select these, and we're going to sort it like this by these columns. So let's see what that looks like. And here you can see it. Grace is ranked 1. Alice is ranked 2 because Grace has the highest salary. Alice has the second highest, and so on within the department. So you can rank them like that. Okay, so there's multiple functions you can actually use within this to find out what you need. So you can do some more thorough data analysis, if you will. We can also use the str accessor, as you can see here. We're going to make it into uppercase, and then we're going to give the new column a new name, and then we're going to select it out of there. So when we run this now, this is what it's going to look like. By making this uppercase, you're making all the letters within this department uppercase. We can also use to find columns that has a certain substring within them. We can use this CS, the selector, matches. Here I'm looking for any column name that has TAR in it, or this vertical bar, DE in it. So let's see what that one, I'm only taking the head, so it'll be the first 5, I believe. And here you can see the department and start date has these combinations in it. Then we have the characters where the length of the column name is less than or equal to 5. And what this one is illustrating to you is that you can use regular expressions as well to find this, okay? You're not limited to literal namings here. You can use expressions like this. So here we're selecting it where the column is between 0 and 5 in length, the characters in it. And here you can see name is 4, years is 5, level is 5. And then here, what we do is we concatenate 2 string columns into one by using this concat string function. So here we're going to concatenate the name plus some kind of literal, as you can see here. And then we're going to concatenate department and some kind of literal again. And then we're going to name it, name the department, or name underscore department. So when you run that, you can see here, name department is Alice, parenthesis, ENG, end parenthesis, which is this portion we just did up here. The final one I want to show you in this video is, and then we'll continue in the next video, is the filter function where a string column contains a substring. So what I'm looking for here is anything that has an A in it. So when the column name, the string contains a substring, and that's what I'm looking for here. So I'll hit enter. We continue in the next video, continuing this workbook. I should say the notebook. So these videos don't get too long. I know you want to sit for hour after hour here. So I'll continue in the next video. See you then.